All right, everybody, let's talk real quick. Get you started on the Conduction Lab. A lot of it's going to be very similar to what you've done. Obvious, I think you'll pop right through it. Again, historically, people pretty much do. Filling out the front here, energy conducts through the metal bar from the hot cup to the cold cup. So we could like draw that. Looks like this is the hot one. The thermometer's up. We could like draw that right on here, saying that energy. Ideally, if the styrofoam worked perfectly, the only energy leaving the hot cup would be through the bar, and the only energy entering the cold cup would be through the bar. Now we know they leak a little bit, no big deal. But the other inefficiency, the big one that we focused on in this lab, and yes, please write this on your thing just to get us all on the same page, is that some energy escapes the bar through radiation. Radiation of energy, right? So the point of the second part of the lab was to try to make up for that, try to fix that with, I think I have it on here. How do we make it more efficient? Add insulation with a U. Let's blow up this document here. Because I know we've talked about insolation, incoming solar radiation. This is insulation, literally wrapping the pipes with stuff to try to make the energy transfer more efficient. Could we have less escape? So let's see if it worked. When you do the lab, and if you ran the numbers at the end of doing the lab, how much did the hot cup cool down? How much did the cool cup warm up? Okay. In other words, how much left here, like kind of measuring the energy through temperature, and how much entered here. And it's not going to be the same number. However much you had leave here will be more than what entered here because some of the energy leaves through radiation, right? So this is really the number that we want to focus on when it comes to our conclusion, which you'll be doing, is this one right here. What is the difference between these numbers? How much did you lose in the first one? And then how much did you lose in the second one? And ideally, if you insulated it and it worked, this on the second time would be lower. You lost less energy because of the insulation. Now, maybe it didn't work. If your insulation got wet, if it wasn't, like again, our equipment, it's not always perfect, right? But that's the goal, is that this would be lower. Now, if you didn't get that goal, that's fine. When you do your conclusion, I'd like you to like write about that. Use your numbers in your conclusion. Use what really happened in your conclusion. Don't fake anything. But you can just explain your way out of it, right? You can say maybe because our insulation got wet, our insulation wasn't wrapped tight enough, or our insulation was junky Walmart stuff. So, yeah, when it's time for that conclusion, I'll come back and talk about these for a quick sec. I just did real quick bullet points of the same stuff that we talked about back when we did the other lab. So this really should be familiar. So I won't beat it to death again. But basically, your choices are going to be, did the insulation, like the big thing to talk about is did the insulation make the energy transfer more efficient? In other words, this number, did it make this number smaller on the second trial? All right. That can really be how you work your explanation. Okay. See how it goes. Let me know if you have any questions. When it's time for rate of change, we've been doing lots and lots of these. I'm hoping they're starting to get familiar. 4 credits. They must have all of the stuff on there. Okay. So what that's going to mean is that when you say hot cup conduction 1, it's changed in value over time. It went over the course of 30 minutes. So it's going to be 30 minutes for all of them. And yes, write it. And then how much did your hot cup cool down? I don't know because I don't know your numbers, right? Let's say it went down by 20 degrees F. I'm just making that up. Use your numbers, please. Then you divide them, hit the buttons on the calculator. In this case, it would be 0.666. Let's call it 0.7 degrees F per minute. All of this has to be there. The labels, the setup, the equal sign, the answer. Okay. So if you want to bang through and go over 30, over 30, over 30, over 30, minutes, then throw in your numbers, divide them, you'll be good to go. Tell me which experiment worked better and why. Supporting with data. No numbers in there, incomplete. Coming right back to you. All right. Good luck, everybody.